Hello dear students, wherever you are, I'm back again with another video lesson. Today's lesson, we will explain section 1 in chapter 4. In this chapter, we have 3 sections. Chapter 4 is about sound. After we finish chapter 3, in this chapter, we will explain about the sound. And in this chapter, as you can see, we have 3 sections. Section 1 is about the sound wave. So we have 3 topics in this section, and section 2 is about the sound intensity and the resonance. And section 3 is about the harmonics and standing waves on a vibrating string and standing wave in an air column. Okay, let's get started our new lesson. In the section 1, chapter 4, we will talk about the sound wave. If you remember, we have 2 types of wave, mechanical wave and electromagnetic wave. So mechanical wave like sound wave, water wave, or the wave of rope. In a mechanical wave, the wave that requires a medium through which to pass. Okay? In a mechanical wave, this wave requires medium. Without the medium, in the vacuum, this mechanical wave cannot pass and cannot transfer energy. Sound wave is an example of mechanical wave. Why? Because the sound wave is a vibrating particles, okay, parallel in the direction of the wave, as we studied in chapter 3. So the sound can transfer energy through the particles, through the vibrating of particles. Okay, so the types of the mechanical wave of sound wave is a longitudinal wave. Why? Because the vibration of particles in a sound wave vibrating parallel to the direction of the wave. What is sound? Is a mechanical longitudinal. Why sound is longitudinal wave? Because it is vibration parallel to the direction of the wave. The vibration of particle is parallel to the direction of the wave. Consists of what? A series compression and rarefaction. Because in longitudinal wave we have rarefaction and compression that traveling or propagating in a material medium. Okay. As you can see, this is a tuning fork. If we start the tuning fork can produce the sound, and the sound consists of compression and rarefaction or stretching. Compression region is the region that has maximum density and pressure, but rarefaction is a region of the longitudinal wave that has minimum pressure and density. Compression, what is compression? The region of longitudinal wave in which the density and pressure are at maximum. What about rarefaction? The region of longitudinal wave in which the density and pressure are at minimum. What are the conditions for the formation and propagation of the sound? In the sound waves are produced by vibrating what? Particles. Without vibration of particles, no sound produces. Okay? And a material medium, okay? So every vibrating of particle requires a medium, okay? Because you know that the particles only exist in the medium, such as air, solid, liquid, and gas. Okay, sound waves, the vibrations of air molecules are parallel to the direction of the wave, as I mentioned. The sound waves are longitudinal wave. The simplest longitudinal wave produced by vibrating object can be represented by a sine wave. Can we represent the longitudinal wave as a sine wave? Yes, of course. What is this? This is compression and rarefaction. Okay. What is this? This is sound wave, consists of compression and rarefaction. Okay, can we represent the sound wave as a sine wave? Yes, of course. How? The region of compression represent for what? Creased. And rarefaction is drop. The compression is in the front of creased, rarefaction hot cream. Okay? So, as you can see in this figure, the creased correspond to what? Compression. Creased, what is this? Creased. And also this is creased. Creased corresponds for which region of longitudinal? Compression. So what about trough? Trough is corresponding for what? For rarefaction. But be careful, guys. If you see this sine curve, okay, and describe this sine wave, is this sine wave is longitudinal or transverse wave? If you see pressure or density, okay, if you see pressure or density here, this sine curve becomes longitudinal wave. Okay, But in the case if you see displacement, this sine curve becomes transverse wave. Okay, like for example, if we have two waves, here we have displacement and here we have pressure. So which one is transverse wave? This one is what? Transverse wave. Why? Because we have displacement here, maximum displacement. In transverse we have displacement. The vibration of particles is perpendicular. Particles are perpendicular to the direction of the wave. But if you see pressure or density, what is this type of sine wave? This is longitudinal wave. What is this? This is longitudinal wave. Why? Because we have pressure here, not displacement. Okay? Look at question 2. Draw the sine curve. Draw what? Sine curve that corresponds to the sound wave. If you draw the sound wave corresponding to the sine wave corresponding to the sound wave, it means that we have to represent this sound wave as a sine curve. Crest corresponds to the compression, trough corresponds to the rarefaction. Okay, as you can see, this is sound wave, consists of compression, rarefaction, compression, rarefaction. Okay, crest corresponds for compression and trough corresponds for the rarefaction. Because air molecules vibrate in direction parallel, the wave is making the series compression and rarefaction. Can you sound wave represent as a sine curve? Yes. The crest corresponds to compression and the trough corresponds to rarefaction. Okay. Now we will talk about the characteristics of the sound waves. What are the characteristics of the sound wave? We have three different types of sound wave. Okay. Sound wave can be classified into three different types. Okay, the first one is infrasonic wave or sound, infrasonic sound. Ultrasonic wave or sound, and audible sound. Okay, we have three. So what are the difference between the infrasonic, audible, and ultrasonic sound wave? So we have to define each of them. What is infrasonic wave? A sound wave that has frequency less than 20 hertz. Okay, what is infrasonic sound wave? A sound wave that has frequency less than what? Less than 20 hertz. Okay, so can we hear less than 20 hertz? No. As we are as a human, we cannot hear this sound. Okay, the human ear cannot hear it, but elephant and whale can hear it. Okay, the second one is audible waves or audible sounds. What is audible sound? A sound wave that has frequency between what? 20 and 20,000 hertz. This is less than what? 20 hertz. Okay, but audible sound is between what? 20 and 20,000 hertz. Okay, and the human ear can hear it. Can we hear the audible wave, audible sound wave? Yes, of course. Why? Because the range of frequency of the audible sound is between 20 and 20,000 hertz. More than 20 hertz and less than 20,000 hertz. We can hear this frequency between this range? Yes, of course. But in the case when the intensity is enough to hear this frequency, because not only the frequency has factor to, for example, to determine which sound is audible. Okay, the frequency is not only factor that determines which sound is audible, but also the intensity has effective to which sound is audible. Okay, the last one is ultrasonic wave, a sound wave that has frequency more than 20,000 hertz. So that is why we say ultra. Okay, what do you mean by ultrasonic? Its frequency is more than 20,000 hertz. More than 20,000 hertz, the sound becomes what? Ultrasonic wave. the human ears cannot detect this sound. Okay, we cannot hear infrasonic and ultrasonic sound because our ears cannot tolerate or detect this frequency. The frequency below 20 hertz and the frequency more than 20,000 hertz. But dog, bat, horse can hear the ultrasonic wave. Okay, as you can see in this figure. What is this range? Infrasonic, elephant, well, they can hear this frequency, infrasonic, okay? But audible sound, the human can determine this sound, which is, range of the frequency is between 20 and 20,000 hertz. Over 20,000 hertz or more than 20,000 hertz, only bat, horse, and dog can hear this frequency. What is the range of the frequency that the human ears can detect? Between 20 to 20,000 hertz. Okay? This is audible. More than 20,000 ultrasonic, less than 20 hertz. More than 20,000 hertz ultrasonic, less than 20 hertz is infrasonic. Guys, which one has longest frequency? Longest frequency. Ultra, audible, and infra. And also for the wavelength. Ultra, wavelength of audible, wavelength of infra. Which one has the highest frequency? Ultrasound wave. Ultrasound wave has the larger frequency because it is over 20,000 hertz. After that, audible, less than 20,000 hertz. And finally, the infrasonic wave has the lowest frequency, which is equal to less than 20 hertz. Okay, which one has the larger frequency? Infrasonic, audible, ultrasonic wave has the largest frequency. Which one has the lowest frequency? Infrasonic. Okay, so because frequency is inversely proportional to the wavelength, okay, at constant speed at a given medium, which one has the longest wavelength? Infrasonic wavelength has the longest wavelength. After that, audible, and after that, if the wavelength of the infrasonic is more than the audible, okay? Sorry, don't necessary to write this. Okay, guys? The wavelength of infrasonic has the longest wavelength. After that, audible, and the last one is ultra. Which of the following has the lowest wavelength? Lowest wave or shortest wavelength? Which of the following sound wave has the shortest wavelength? Ultrasonic wavelength. But which one has the highest frequency? Ultrasonic wave has the highest frequency. So what about velocity? Speed of ultra, speed of audible, speed of infra. Which one has more speed at a given medium, guys? At a given medium. At a given medium, all sounds are traveled with the same speed, no difference. Okay? Because the sound wave does not depend on frequency and wavelength. The sound wave depends on what? The type of medium, type of wave, and the temperature. Okay? Which of the following sound wave has highest speed, for example? The speed of velocity or the velocity of sound, in which of the following sound waves are more? Okay, which one has more speed? You have to say all types of the sound wave, they are travel at a given medium at the same time at the same rate. Okay, they all have the same speed of sound at a given medium, as you can see in this figure. So this is very important. Pay attention, please, because it has been brought in the Wizari exam many times. Did you understand? Okay, well, what does an individual's hearing depend on? Okay, what does an individual hearing depend on? It depends on the person's age, because the individual hearing depends on the person's age, because for example, the old person, always they have a problem with the hearing, okay, because the person's age has effect of hearing. Okay, the old man always they have a problem with the hearing. Okay, but the young peoples they don't have a problem. Okay, when the age increases, the hearing becomes difficult and more difficult. The second one, experiences with the loud noises. The loud noises also has effective for hearing. Okay, like for example, if you're hearing an explosion or something like that, our ears becomes damaged, and in that case, we cannot detect the sound. Okay, so what does the individual hearing depend on? It depends on two factors. The first one, the person's age. Okay, the second one, experiences with the loud noises. What does the range? Guys, this question is different with the previous question. What does the range of audible sound wave depend on? The range, the ability of the average human ear to detect their vibrations. If the human ear can detect this vibration, we can hear this sound. Which types of the sound we can detect the vibration? Audible sound. More than 20,000 hertz, less than 20,000 hertz. Okay? For example, dogs and bats can hear the ultrasonic waves. Why? Because they can detect this huge frequency, but humans cannot. Okay? What are the uses of ultrasonic wave? Ultrasonic wave. In ultrasonic wave, frequency is maximum, okay, or frequency is the highest. It has some applications, okay. What are the uses or applications of ultrasonic? Can be used to what? Produce image of object inside the body. Why? Because it has more frequency, okay. For example, this is like a stone in the kidney, okay. If someone suffered with the kidney pain, if they have a small stone in the kidney, how can the doctor see this small stone inside our body? By using what? By using ultrasonic device. What is the ultrasonic device or ultrasound device? Ultrasound device is the device can be used to detect or to see small object inside our body. Why? Because ultrasonic wave, ultrasound wave, it has more frequency. Okay? It has what? More frequency, highest frequency. So this highest frequency, when the incident frequency, sorry, okay guys, as you know, the ultrasound wave can be used to detect or see the small object inside our body, okay? Why? Because the ultrasound wave, it has highest frequency, okay? This highest frequency, when the incident frequency, when they hit the small object, okay? This is small object, okay? Like a stone in our kidney. So we can produce image by using ultrasound wave when this frequency hits this small object, okay? It's gonna be this incident frequency, it's gonna be reflect. Why? Because of the shortest wavelength and the highest frequency, they can reflect when they strike an object, okay? But be sure that this wavelength must be less than the object. If the wavelength is bigger than the object, the frequency cannot be reflected, okay? Guys, for ultrasonic waves to see an object inside the body, the wavelength of the waves used must be about the same size or smaller size. If the wavelength is bigger than the size of the object, the wave cannot be reflected by the object. What are the types of ultrasonic or infrasonic waves? They are longitudinal waves. All types of sound wave, such as ultrasound wave, infrasound wave, audible sound wave, all of them, they are longitudinal wave. Why? Because all of them is a sound. Okay, so the sound is a longitudinal wave, which is it is particle vibrating parallel to the direction of the wave. Why do ultrasound wave produces image of object inside the body more effectively than audible sound wave do? What is the difference between the audible sound and ultrasound? Ultrasound has more frequency than the audible sound because of their high frequency. and their short wavelength, okay, can image small objects. The image produced by the ultrasonic waves are clear and more detailed than those can produced by the lower frequency sound waves, because the short wavelength of the ultrasound wave are easily reflected of a small object. Audible and infrasonic sound wave are not as effective because their longer wavelengths pass around a small object and cannot be reflected. Okay? A typical frequency used in the ultrasonic device is about 10 megahertz, but this is skipped, okay, because this is related with the inside story of ultrasound image. Guys, this inside story is skipped, okay? Another topic in this section, guys, is what? Frequency determines speech. Okay? If you remember, in a sound wave, we studied what? Velocity of the sound wave, frequency of the sound wave, wavelength, amplitude. Okay? But today's lesson, we will study a new thing, which is pitch. What is pitch? A measure of what? How high or low a sound is perceived to be. Okay? What is pitch? Once again, a measure of how high or low sound is perceived to be. Depending on what? The frequency of the sound wave. What is the relation between pitch and frequency? More frequency has more pitch. Okay? Frequency and pitch is directly proportional. Okay? More frequency has more pitch. What does pitch depend on? Pitch depends on what? Depends on frequency, directly proportional. More frequency, more pitch. Background noise and loudness. With the background noise, pitch is inversely proportional. Why? Because in the background noise, there is too noisy and there is a lot of sound, so that is why the pitch decreases. Okay? And also with the loudness is directly proportional. What does pitch depend on? It depends on these three factors: frequency, background noise, and loudness. We have some notes about frequency. As you know, the frequency of an audible sound wave determines how high or low we perceive the sound. This is called a pitch. As the frequency of the sound increases, the pitch rises because directly proportional. High sound have high pitch and low sound have low pitch. Therefore, a woman's sound is shriller and more screaming than the man. Okay? Which one has more pitch? A woman or man? A woman absolutely has more pitch. Okay, because it has more frequency. What factor change as the pitch gets higher? This is a very good question. When the pitch gets higher, which of the following changes? Frequency, does the frequency change? Yes, of course. If the frequency changes, also wavelength changes? Yes, of course. So the frequency and wavelength, both of them changes by changing pitch. Which of the following changes when the pitch gets higher? Frequency and wavelength, both of them. When the pitch gets higher, frequency increases, pitch decreases, because frequency and wavelength is inversely proportional. What is the difference between frequency and pitch? Frequency, this is question 3 in chapter review, very good question. What is the difference frequency and pitch? Sometimes the students are struggle to compare to difference between, to make a distinguish between frequency and pitch. Frequency is what? An objective measure. Objective measure, it means that the frequency, it depends on the person, okay? It depends on what? The person itself, okay? Of the rate of particles vibration. It depends as an objective measure of rate of particles vibration. But pitch, pitch is a subjective quality. What is this? Subjective quality. Depends on what? On the listener. The listener can detect the pitch for someone. Okay? For example, sometimes we don't like the shriller or screaming of the woman and the crying of the children. Why? Because they have more pitch. Okay? Who can determine this pitch? The listener, the observer, the someone who's in the front of this guy when has more pitch. Okay? That is why it depends on the listener. What is the relation between pitch and frequency? Directly proportional. More pitch has more frequency. Okay? Another topic, speed of sound. Okay? We will study the speed of sound. As you know, all speeds has a sound. Okay? So the speed of sound is faster in solid than liquid and gas because of the particles. As the particle approaches to each other, so far, what happened to the speed of the sound? The speed of sound increases. The speed of sound in which of the following mediums are faster? Solid, liquid, or gas? Absolutely in the solid. Speed of sound in solid bigger than speed of sound in liquid and more than the speed of sound in air. In a solid at a given temperature, speed of sound approximately 5,100 meters per second. But in the liquid at a given temperature, like in the ocean at 20 Celsius, approximately 1,500 meters per second. But the speed of sound in the air at a given temperature is about 340 meters per second. Which one has most speed of sound? Absolutely the solid medium. Okay? So this is the example. Gas, 330, 40 approximately. Okay? For the water is liquid, approximately 1,490 or 1,500 meters per second. Aluminum is solid, 5,100 meters per second. Sound wave can travel through solid, liquid, and gas. Because waves consist of particle vibrations, the speed of the wave depends on how quickly one particle can transfer its motion to another particle. Sound wave generally travel faster through what? Solids than through the gases. The speed of sound also depends on the temperature. When temperature increases, what happens to the speed of sound? Also increases. Is directly proportional. More temperature has more speed. Look, air at 0 Celsius has 331 meters per second. What about air at 100 Celsius? What happens to the temperature? Increases. What about speed? Also increases from 331 to 366 meters per second. So, as the temperature rises, the particles of a gas collide more frequently. The action of the temperature is less noticeable in liquid and solids because their particles are close enough together, which means that increasing temperature is more noticeable in gas than liquid and solid. Guys, this note is very important. And the last year, this question has been brought in the Wizari exam. Guys, look at this note number 4. Which of the following medium has more speed or most speed of sound? Solid, liquid, or gas? Solid. Once again, listen carefully. Which of the following medium has more speed of sound? Or the speed of sound in which of the following is faster? Solid, liquid, gas? Solid. Okay? But if I ask you another question, increasing temperature or the action of temperature, in which of the following mediums has more effective? Gas. Okay? For example, like in the winter, when you are using a warmer device that goes to increasing the temperature, in the room, what we have solid, like the handle of the door, and also we have a bucket of water, okay, a bottle of water, or we have liquid also, and also we have air in the room, okay? For example, if you increase the temperature of the air conditioner, which of the following medium its temperature increases? Air, okay? At first, the air becomes warm. After that, liquid, after that, solid. Why? Because the particles of the air is far away from each other, so they need less energy to transfer it. Look at question note number 4. The action of what? Action of temperature. Action of temperature is less noticeable in liquid and solid. Why? Because of the particles are close enough together, which means that the increasing temperature is more noticeable in what? In gas. Increasing temperature is more noticeable in which of the following? Gas, liquid, solid, gas. But speed of sound in which of the following medium is faster? Solid. Okay? Note number 5, sound is a type of wave, so the same law of the wave is applied. V is equal to wavelength times frequency. By changing the medium, the frequency of the sound does not change. Guys, by changing medium, the frequency does not change, but speed, wavelength, and amplitude of the sound wave changes. Okay? So how did we get this equation? V is equal to wavelength times frequency. Okay? For example, if we represent the sound wave, this is pressure, sound wave as a sine wave. Okay? So what is the distance? What is this distance? This is eches, which is equal to wavelength. Okay, this distance is displacement, which is equal to wavelength. Okay, if you remember in grade 11, you studied this. Velocity is equal to what? X over time. Okay, for one complete cycle, one complete oscillation, one complete cycle, delta X is equal to what? Is equal to, and instead delta X, write down what? Wavelength. For one complete cycle, T time interval is equal to what? Is equal to period. And instead of this T small, write down what? Period. Okay? Wavelength over, instead of period, write down what? 1 over frequency. Okay? According math basic, you can flip this fraction. Okay? Velocity is gonna be wavelength times frequency. Okay? How can we determine the velocity of sound wave? Velocity of sound wave, wavelength over period, or wavelength times frequency. Both equations can be used to find the speed of sound. What does speed of sound depend on? Types of medium, and the temperature is directly proportional. Why the sound wave travel faster through the solid? Because molecules of the solid closer to each other. That is why it is faster. Okay. Why the speed of sound increasing by rising temperature? Because when temperature rises, the particles of gas collide more frequently. Okay? Guys, look at question 5. Explain why the speed of sound depends on the temperature of the medium. Why? Why the speed of sound depends on the temperature? Because molecules that have more motion, high temperature, can transfer their vibrations more easily. Okay? By increasing temperature, what happens to the collision between the particles? Increases. When the collision of the particle increases, what happens to the friction? The friction also increases. This friction, it goes to increasing temperature, and it goes to moving particles fast and fast. Why is this temperature depends? Guys, this temperature dependence more noticeable in what? In gas. Okay? The temperature dependence is more noticeable in what? In gas. The action of temperature is more noticeable in gas than solid or liquid. Why? Because this is less noticeable in liquid and solid, because their particles are closer together. The particles of solid and liquid are close together, okay? So they require more energy to their temperature increases, okay? If the wavelength of a sound source is reduced, guys, if the wavelength of what? Sound source is reduced by factor of what? 2. Okay, wavelength becomes what? Reduces by factor of 2, it means that becomes half. What happens to the wave's frequency? In the sound source, it means that the source is given, temperature is constant. What happened to the frequency? Because frequency is inversely proportional to the wavelength, becomes half, frequency becomes double. It becomes what? Twice. When the wavelength decreases or reduces by factor of 2, frequency becomes double. So what about the speed? Because the sound source is given, the speed remains constant. Speed does not depend on frequency. Speed does not depend on the frequency at a given medium. This is constant at given medium. When wavelength becomes half, frequency becomes double. And vice versa is true, okay? As a result of a distant explosion, an observer first senses a ground tremor. Then hears the explosion. What accounts for this time lag? Okay? So, as a result of the distant explosion, An observer first sends in what? In the ground. Ground is solid or liquid? Solid. Because the sound is moving very fast in the ground, which is solid state. That is why we can hear and we can determine the sound. And the sound travels faster through the ground than the air. That is why we can sense first in the ground tremor. Okay? The range of human hearing extends from approximately 20 hertz to 20,000 hertz. Find the wavelength of this extreme when the speed of the sound is equal to 343. The speed of sound is constant. The first frequency was given 20 hertz. The second frequency 20,000 hertz. Speed in both cases constant, 343 meters per second. Determine the range of the wave. Wavelength number 1, wavelength number 2. Wavelength is equal to what? V over F1, 343 divided by 20, which is equal to 17.15 meter. But for the second wavelength has more frequency, less wavelength. Less frequency, more wavelength. At constant velocity speed of sound. The second wavelength, V is constant over F2, 343 divided by 20,000, which is equal to 0.02 meter. Okay? Because in that case, according to the given value, F2 bigger than F1, lambda 2 must be less than lambda 1. Look, this is lambda 2, this is lambda 1. But V1 equal to V2. Okay? Question 33. A dolphin in 25 Celsius. Guys, look at this question. It's a very good question. Dolphin in a 25 Celsius seawater emits a sound. Emit what? Sound. Okay? This is dolphin. Assume that this is dolphin. Okay? Emits sound. Okay? Emits a sound directed toward the bottom of the ocean. Okay? What is this? This is the ocean. Okay? This is the bottom of the ocean. The bottom of the ocean is 150 meters below. Okay? Emits a sound. What is this? This is the bottom of the ocean. How many meters? 150 meters. X is number 1. Okay? This is X1. Okay? How much time passes? What is unknown? Time. Time is unknown. Passes before it what? Here's an echo. What do you mean by echo? It means that when the dolphin emits the sound, and also the dolphin can get it is echo. Okay? What is this? This is echo. For saving data. Okay? What is this? This is echo. What is the unknown? How much time passes? How much time passes when they get the echo waves? Okay? As you know, at first the sound wave passes how many meters? 150 meters. Okay? But this sound is also reflected by the ocean. It also goes or covered another x2, which is equal to 150 meters. Okay? If the question said how much time or how long does it take for the emitted sound wave when it reaches the bottom of the ocean, you have to use only 150. But because the echo is mentioned in the question, it means that how much time passes before it hears. Okay, it means that returned path. Okay, time is unknown. V is equal to what? See table 4.1 to find the speed of the wave, which is equal to 1,530 meter of the ocean. This is speed of sound in the ocean. T is unknown, but X total is equal to what? 150 plus 150, which is equal to 300 meter. Okay? To find the time, V is equal to what? V is equal to X over T. Rearrange equation. T is equal to what? X over V. Why? Why delta X is 300? 300 divided by 1530. Why we have to use 300? Why we didn't use 150 meter? Because we have to find the distance of the round trip, okay? Not only the image, we have to count we have to count the echo as well, okay? Sending out reflection is equal to 300 meter. Time is equal to what? 0.196 second. The time that takes for the dolphin to receive the echo of the wave, okay? That's all for today. Inshallah, in the next lesson, we will continue explaining section 1 in chapter 4. Thank you for listening. See you again, inshallah.